Hello everyone, so today I'll be discussing question number 33 of GATE 2008. The members E, J and IJ of a steel truss shown in the figure below are subjected to a temperature rise of 30 degrees Celsius. The coefficient of thermal expansion of steel is given. The displacement of joint E relative to H along the direction HE of the truss is. So we are asked to find the relative displacement between joint E and H, and 4 options are given to us. It's a 2-mark question. For this problem, we will use the unit load method, which is based on the virtual work principle, to find the relative displacement between joint E and H. So according to unit load method, the displacement of any joint is given by summation of Ui into DLI, where Ui is force in ith member due to unit load, while DLI is change in length of ith member due to external load. In this case, the external load is temperature. Therefore, change in the length of ith member will be Li alpha I delta Ti. So finally, the displacement will be calculated as summation of Ui multiplied by Li alpha I delta Ti. So this is the final formula we are going to use for this problem. Now, where to apply the unit load? So unit load we have to apply at that location or at that joint where we have to find the displacement. So in this problem, we are asked to find the relative displacement between joint E and H along HE. So we will apply the unit load at E and H along the direction HE. Okay, so this will be the assumed direction of unit loads. Since the line of action of these two unit loads are same, therefore the reactions will be 0. Since there is a 0 reaction at this support, therefore these two members will be the 0 force members. Now we need to find the forces in the remaining members due to the unit load, which will become our Ui. Now let us calculate forces in all the members due to the applied unit load. So first of all, we will assume tension in all the members due to the unit load. So here is the applied unit load 1. Let us consider this angle as theta, and this theta is 45 degree. Therefore sin theta is equal to cos theta will be 0.707. Now let's one by one calculate all the forces. Let's consider joint H first. Summation of force in vertical direction to be 0. What is the force in vertical direction? F JH plus 1, this is 1, sin theta equal to 0. This means FJH is equals to minus sin theta. We can say that FJH is equals to minus 0.707. So FJH we have calculated. Now let's see joint H again. F force in horizontal direction to be 0. So therefore GH plus 1 cos theta equal to 0. Therefore FGH is equals to minus cos theta, and cos theta is 0.707. So we have calculated FGH also. Now let's calculate the remaining forces. Now let's consider joint E now. So we are considering joint E. Summation of force in vertical direction to be 0. This means that FEG plus 1, this is theta, so this will be theta, FEG plus 1 sine theta equal to 0. This means that FEG equals to minus sine theta or minus 0.707. So we have calculated FEG. Now again we'll do summation of force in horizontal direction to be 0. From this we will get FEJ plus 1 cos theta equal to 0. So FEJ plus 1 cos theta equal to 0. From here also we get the value of FEJ as minus 0.707. Now the only member that is remaining is FGJ. Consider joint J now. So we are seeing joint J. Summation of force in, let's say, vertical direction to be 0. Therefore FGJ plus FGJ sine theta plus FJH is equal to 0, because we are taking force in summation of force in vertical direction as 0. Therefore FGJ, that is this member, sine component of this member, plus FJH equal to 0. Therefore we'll put FGJ sine theta plus, what is the vertical member, FJH equal to 0. So FGJ sine theta is minus 0, sine theta is 0.707. And what is FJH? We have already calculated FJH. FJH is minus 0.707. So it is minus 0.707 equal to 0. This from this we get FGJ as 1. So now we have calculated internal forces in all the members due to the applied unit load. Now from we have already discussed that we'll use our formula summation of UI multiplied by DLI. Here the change in the length of the members due to the external load is only due to the temperature, because the external load here is only temperature. Therefore our DLI will be Li alpha I delta Ti. So this is the final formula we are going to use here. To implement this formula, we will make a table. So this kind of table we will make, in which there is member, there is a column named member. Here we have written the names of all the members in the truss. There is a column in which we have to fill the internal forces, which we have already calculated. Here we have to fill the length of each member. Here we have to fill alpha I, that is coefficient of thermal expansion of each member. Here the temperature change in each member, and finally we have to implement a final formula. Please note that in this question we are only given the temperature change in two members, that is member EJ and IJ. For all the other members the temperature change, that is the delta T, is 0. So other than EJ and IJ we can fill the delta T, that is temperature change, to be 0. So we will fill 0 in for all the other members. For EJ and IJ the temperature change is given as 30 degrees Celsius. So we can see that we do not have to fill all these columns for all these members. Why? Because finally when we'll multiply it with delta T, this all the things will become 0. We only have to care about now these two members, that is EJ and IJ. So what is the UI, that is the internal force due to unit load in member EJ. In member EJ, the value of UI is minus 0.707. So we'll write minus 0.707 here. What is the UI for member JI? For member JI is a zero force member, so UI is 0. So for this member also, that is member JI, this after multiplication, this term will become 0 because 0 is here. Okay, so if we'll multiply anything by this 0, this entire term will become 0. Now we have to only worry about the member EJ. What is the length of member EJ? The length of member EJ is 3000, right? So we'll fill this table now. So this, for this member, the length is 3000. What is the value of alpha I? The value of alpha I is this. So after multiplication, we'll get this value as 0.764. Now we'll add all these values. So other than this 0.764, all the values are 0. So our final value of summation UI, Li, alpha I, delta Ti is 0.764 mm. So from the options we can choose our option as 0.764, which is our final answer. So in this question we can see whenever there is a temperature change and no other external loading, we have to calculate the forces in only those two members, because other than that all the values will become 0 finally. So here if we are given the temperature change in member EJ and IJ, so from starting only we should calculate the value of UI for only these two members. So I hope this is clear. So our final answer is 0.764.